Hi everybody, I'm Professor Rad, and today we're going to talk about the Cartesian plane and graphing ordered pairs. We've got a bunch of terminology at the beginning, so we're going to front load a big definition, and then we'll work through a few problems together. So let's start out with all these definitions, and then I'm just going to work through them, and then we'll kind of visualize them and see what they look like as we go through the examples. So we're going to start out with something called an ordered pair. Now, we talked about ordered pairs when we discussed ratios for this class. So an ordered pair is a pair of numbers, right? It's made up of two numbers or two variables. We've got something called an independent variable, which we usually represent with x, and a dependent variable, which we usually represent with y. And ordered pairs are always written in the form x, y. They're always written in parentheses. X is always first, y is always second, and there's always a comma between them. Okay, so you do need these parentheses, and you need the comma for your ordered pair. Now, we can graph an ordered pair as a single point on a Cartesian plane. Sometimes referred to as the coordinate plane. By graphing the independent variable along the horizontal x-axis and the dependent variable along the vertical y-axis. Okay, let's pause for a moment here and talk about this a little bit. So the Cartesian plane, it's named after a guy named René Descartes, who was a French philosopher, so he's attributed with coming up with the system of graphing ordered pairs or visualizing ordered pairs. When we visualize them, basically what we're doing is we're taking two number lines, one that goes horizontally and one that goes vertically, and we're crossing them to help us plot or help us visualize the x variable along the x-axis, that's our horizontal axis, and the y-axis, that's the vertical axis. Once we go through some examples, it'll become clear how we use this to visualize ordered pairs. The point where the two axes cross, so this point here in the middle, is called the origin. And the coordinates of the origin are 0, 0. That's because if I look at the x-axis number line, right, we've got -6, 4, 2, and then here's where the x value would be 0, and then 2, 4, 6. So the x value is 0 on the origin. And same thing with the vertical number line. So you can notice it starts out bigger positives, they get smaller until they get to 0, and then they become bigger as they go to the negative area. So on here on the y-axis, the y value would be 0 as well. So let's go ahead and do some examples of plotting points on a Cartesian plane. All right, so I've got 3 examples for us to work through together in this video. So first we're going to graph through each set of ordered pairs on a Cartesian plane, and we'll label each point with its corresponding letter. So this one that we're starting out with is the same grid that we saw on the previous page with those definitions. Just like when you're creating a number line to graph like a number, you want your grid to kind of span the distances of your ordered pairs. So for example, in this case, when I look at all the x values, I have a 5, a -6, a 2, and a 0. So like the biggest negative is this -6. So I have to make sure I go at least to -6 on the left. The biggest positive was a 5, so I have to make sure I go at least up to 5 on the right. And then same thing with the y values. So here it looks like I have a bit more space for the y-axis than I might need because the y values, the biggest negative is -3, and I go quite a bit further below that, and the biggest positive is 2. I go a bit above that. But if you're creating the grid yourself, that's the kind of thing you want to bear in mind. To graph a point, I think of it as like starting at the center and moving according to the directions they've given me. So the directions they gave me here say go to the right 5 spaces or go to the right to 5. So here's where 5 is. Then I have a -2, so I'm going to go down 2 spaces, and that's where I plot the point. So if I use the x-axis and the y-axis as reference for this point, when I look to the horizontal axis, it's at 5. And when I look over to the y-axis, it's at -2. Then they want us to label that A. The next point, B, I'm going to start at the middle and follow the directions. So it says go left to -6. So I go left to -6. And then since it's a +1, I'm going to go up to 1. It's always left or right and then up or down, right? You're going to walk across the floor first and then you take the elevator. So we have B here, that one. Now C is the ballerina point because it's 2, 2. So I'm going to start at the origin and I'm going to go over to 2 and then I go up to 2. So there's C. And then D is kind of an interesting point because the first coordinate is 0. So that means when I'm starting here, I don't go left or right at all. I'm just stuck here. But I do have an up or down movement. I'm going to go down to -3, which is over here. So that's my point D. All right, let's go ahead and look at another example. So this time I notice that the graphing space is a little bit different than what we had before. So I notice that like over up here, each line represented 1, but now each line is representing a half. So we've numbered 1, 1.5, 2, 2.5, 3, and so on. And this makes sense because if I look at my ordered pairs, the numbers aren't super big. So the biggest I see are 3s, but we do have 0.5s. So we do have those 1/2s. So I'm going to graph them in the same way, start at the origin. And for this first point A, we're going to go over to -1. So over here. And then we're going to go up to 1.5. So based off of my grid, if I look at this vertical axis, this is a half, 1, 1.5. So I'm here at -1, and then I want to go up to 1.5. So those two meet right here. Let's try another. We've got -3, 3. Now, because of the scale on my number lines here, my axes, I can't just count 3 spaces. I have to count over to where -3 is, and then we're going to go up to where +3 is, and where those two meet is where we're going to plot the point. All right, let's try this next one, K. So we're going to go over to 3, okay, and then down to -1.5. So this is -0.5, -1, -1.5. All right, one more to go. So here we have an x value of 1. So I'm going to go over to 1. Oh, and the y value is 0. So that means I don't go up or down at all. So I'm just going to be right here at the 1. Okay. Let's do one more together. Oh, golly. Okay. I noticed some mixed numbers and fractions. Okay, but remember, mixed numbers and fractions, they're just numbers, just like anybody else. Well, just like any other number, I guess. So we can graph them just the same as we can any other number. They're just require a little bit more thought. The other thing I'm noticing is that this is a very different Cartesian plane from the ones that we've seen. The ones that we've seen so far have had the axes smack dab in the middle, but on this one, they're not crossing at the middle. So like the positive x-axis only goes up to about 4, whereas the negative x-axis goes down to -6. And it looks like each of these is representing 1 as I'm counting along my x-axis. For the vertical axis, it's very different because it goes down to -1, up to 2, and it looks like each unit was split up into 1, 2, 3 pieces. So each of these is representing a third. So maybe that's going to help us graph these fractions and mixed numbers. We'll find out. But one of the things that this is pointing out is that since you have 2 number lines and you can break up number lines based off the numbers you need to graph, you don't have to have the same scale for your x-axis as you do for your y-axis. They can be different. So that's to help us graph numbers more precisely, but it can also make things a little bit more confusing when you're counting the lines. So if you've been provided with a grid, you always want to acquaint yourself with that before you start plotting points. So the good news is this very first point, G, easy, 3, 2. No fractions, nothing strange going on here, both positive. So I'm going to go over to 3 for the x value, and then the y value is 2, and I'm going to see where those meet, and I'm going to plot G. Okay, now we have -2, and then 1 and 1/3. Now this 1/3, I'm actually kind of happy that it's 1/3, because remember when we were counting up here, I said a unit was divided into 3 pieces. So I know that this is 1/3, 2/3, 1, 1 and 1/3, 1 and 2/3, 2. So 1 and 1/3 is going to be this line here. -2 is going to be this line here. So they both meet here. Okay, and that point is I. Whew, okay, point K, -6, 0. So the x value is -6. The y value is 0, so I don't go up or down at all. So I'm just going to plot that point here. And then we have n, which is 1 and 1/9 and 1 and 7/9. Oh gosh, okay. So when we had just a plain number line, and if I wanted to graph 1 and 1/9, and if I wanted to graph 1 and 7/9, just as a review, we'd have our 0, 1, 2. And because these denominators were ninths, we would split these up into 9 equal-sized pieces. So all right, 1 and 1/9 means we're going to start at 1 and we go to that first line afterwards. 1 and 7/9 means we're going to start at 1 and we're going to count to the 7th afterwards. So when we were graphing on a number line, that was our strategy for dealing with mixed numbers and fractions. So we're going to apply that here. We've got 1 and 1/9 for the x value. So I'm going to bring a pencil in here. I'm going to zoom into my x-axis. because I want to get 1 1/9. So I'm going to start at 1 and I need to go 1/9 of the way over. So I'm going to split that up into 9 equal-sized pieces. Ish. And I want the first one. Okay. So this is where I'm looking for my x value. The y value was 1 7/9. So I'm going to go to my y-axis and I'm going to go from 1 to 2 and split that up into 9 equal-sized pieces. Now these are a little bit bigger because I'm going all the way up to 2. And also, since I know that 9 is 3 times 3, I split each of these blocks up into 3 pieces. So if we counted, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. We are graphing 1 7/9, so we want the 7th one. 1, 2, 3, 4, 5, 6, 7. Okay, so let's zoom out again to get the bigger picture here. Oh golly, shaking the screen. All right, so here was our 1 7/9. Here was our 1 1/9. So we're going to travel just past that line up to about here. And that's point N. So you can graph fractions and mixed numbers on a Cartesian plane. And again, they're not, anything to be scared of. They just take a little bit more, time and processing. So don't be afraid to kind of go back to your roots here and draw out a number line and think, how would I graph 1 1/9? Or how would I graph 1 7/9 on a number line? Because the method that we used here, we're going to use here as well. We just might have to be a little bit, careful about how we do it. So, got a few now you try questions for you to work on. So I don't know if I can zoom out all the way here. Oh, you'll see a little bit. But yeah, so we've got graph each set of ordered pairs, and I have a few suggested grids that you can use to graph them. In the next video, we will continue our conversation about the coordinate or Cartesian plane or coordinate axes, and but we'll be looking at ordered pairs presented in a slightly different way. So I hope you found this video helpful, and I will see you next time. Bye for now, everyone.